Hello guys, welcome sa continuation of our lecture, Deflection on Beams, and for today we will be discussing one method in solving for the slope and deflection of our beams using double integration method, right? So to start, this is our outline for today. We will be formulating yung deflection equation using yung knowledge natin dun sa pag-identify ng moment at each segment. Then we will be utilizing the double integration method. That's why I asked you to review your integral calculus on how to evaluate yung mga integrals natin. And then we will be moving forward in solving some examples to demonstrate how this method is performed. Okay. For the outcome of this lecture, we have the following. First is to demonstrate to you how the slope and deflection of beam is calculated or formulated. And then next is to derive how the double integration method for slope and deflection is formulated. And then last is to solve the slope and deflection of a given beam condition. Okay. All right, so let's start. As an introduction, the double integration method is a powerful tool in solving deflection and slope of a beam at any point because we will be able to get the equation of the elastic curve. Because from our previous lecture, we were able to qualitatively assess what will be the elastic curve ng beam natin given the different loadings na meron tayo. If we cannot identify the elastic curve directly by inspection, we can use yung moment diagram natin to know what will be the elastic curve of our beam. Okay? So for this particular beam, we have a simply supported beam with x axis natin as x and vertical direction natin as v. Okay? And then when we have the elastic curve here, when we want to know yung deflection niya and yung slope niya at any section ng elastic curve natin, we can actually select any point dun sa elastic curve natin. So let's say the point that we will consider is this point. Okay? So yung vertical distance, okay, nung mula dun sa original location ng beam natin from the assumed deflected shape natin, yung height na yun o yung difference in the v-axis natin is called our deflection. So, ayan yung vx natin. So, what is yung slope natin? So, when we try to pass a tangent line across dun sa point natin, okay? Ayan ba, naglagay tayo ng tangent line. Okay? Then when we measure yung inclination ng tangent line na yon with respect sa horizontal axis, yun yung theta ang tinatawag natin. Okay? So this is our theta. Okay? And that theta can be represented by the change in our vertical axis or yung vertical measurement natin and do sa ating horizontal measurement natin. So with this, we can know kung ano yung ating slope nung given elastic curve natin at a given point. Pero ang pinaka-goal natin, beside knowing the slope of the curve or of the elastic curve, is yung deflection natin dun sa particular point na kinoconsider natin. Okay? So based from this diagram, we can say na to get yung theta natin, the value of theta, we can use a trigonometric function kasi meron tayong right triangle sa kanya dito, no? So we can use yung tangent natin. So using tangent of theta, that is equals to dv over dx or opposite over adjacent nung right triangle natin. And then, according to our assessment before, yung elastic curve natin is just an exaggeration lang ng mismong magiging deflection natin. In real life, hindi siya ganyan kalaki, no? Matakot ka pag ganyan siya kalaki. Usually, hindi siya visible right away sa naked eye. So we can assume na yung value ng theta natin would be very small. And according to small angle theorem, si tangent theta natin, we can assume that to be equal to theta lang din. Okay? So from this assumption, we can say na si theta can be now be equals to our dv over dx. So yung change natin in the vertical direction over sa change natin sa horizontal direction. Okay? Then when we try to cross multiply this one, we will have a value na dv is equals to theta dx. Then when we try to integrate both sides, we will have v is equals to the integral of theta dx. Okay? And this v is our deflection. Okay? Kasi yan yung ating dito no sa vertical axis natin. Pero we cannot integrate yung right side natin kasi si theta should be represented in terms of x. Okay? And alam naman natin na sa integral, kailangan kung ano yung ating variable dito, kailangan dun yun din yung in terms ng ating quantity dito. So sa theta, we should represent theta in terms of x. And how can we do that? We can do that by considering yung bending moment ng beam. And sa bending moment ng beam, marunong na tayong maghanap ng equation niya along x, no? Kasi 'di ba before nagka-cut tayo ng section. And then once we identify yung moment niya, pag nagka tayo, nagkakameron tayo ng moment function natin. Yung moment function na yun, that will be the one na gagamitin natin. Pero paano natin yung papalabas si moment kung si theta yung nakalagay dito? Okay? So we must consider some derivation pa, no? So moving on to the next slide, consider halimbawa yung beam natin and then we loaded yung beam natin, let's say nag-deflect siya ng ganito. Okay? So pag nag-deflect siya ng ganyan, what happens dun sa beam natin? Yung top fiber niya is nagko-compress, no? In compression siya. And then yung bottom fiber niya is in tension. Meaning, yung nasa taas niya is nag-shorten, okay? And then yung ilalim niya is nagle-lengthen kasi nga nag-bend yung mismong beam natin. So ibig sabihin, itong portion na to, pwedeng tawagin natin na compression zone. And then yung other side, pwede natin tawagin as yung ating tensile zone. So ano nangyayari dun sa mga zones na yan? Sa compression zone, yung fiber natin, nag-change yung length niya. Nagiging siyang smaller yung length niya kasi nga nagko-compress siya. Sa tensile zone, kabaliktaran, so nagla-lengthen naman yung length natin. Pero dito sa particular fibers natin, sa zone natin, meron diyang surface na hindi nagbabago. And yung hindi nagbabago na surface na yan is represented by this red line. Okay? Yung red line na yon tinatawag natin as our neutral zone kapag three-dimensional yung pinag-uusapan natin or neutral axis na tinatawag natin. Okay? Ibig sabihin, in the neutral axis, ito yung location inside the beam where yung length does not shortens nor lengthens. Okay? So it stays the same as the original length. Okay? And based from this definition, we can actually derive yung value ng theta. So let's consider a beam ulit, yung same beam natin. And then we consider a small segment ng beam natin. Sabihin natin, i-cut natin to. Then when we try to load this beam, ano yung magiging kanyang deflection? Pag nag-deflect yung beam na yan, exaggerated lang to, no? Yung beam na yan, pag nag-ano siya, okay, pwedeng ganyan yung deflection niya. Okay? Okay, so yan yung deflection natin. And pag nag-deflect yan, siyempre ito yung kanya neutral axis, ang nangyayari is para siyang nag-deflect na as an arc of a circle. Okay? So kung arc siya ng circle, ito yung center ng circle, meron tayong tinatawag na radius kung circle yan. And then ito yung segment ng circle, okay, na pwede natin tawagin na ds, no? Or same siya as dx dito sa original beam natin. Okay? And then, ano yung nangyayari dito? Um, itong segment natin na to, meron siyang theta dito. This theta is taken from yung difference nung mismong ano natin, nung curve natin. Kasi itong curve na to, meron siya ditong angle, okay? And meron siya ditong angle. Okay? So, angle with the horizontal and angle with the horizontal. So, ito, pag pinag-combine natin, ito yan, yung theta niya, equals to sa theta na yun. Okay? So, ano bang formula na pumapasok sa atin when we see an arc of a circle? To verify or to know yung value nitong segment na to, we have a formula of S is equals to R theta para makuha natin yung arc length. Pero dito sa figure natin, we can represent that as ds is equals to R d theta. Okay? Kasi nga, that is a very small portion lang. Okay? And si R dito, anong tawag natin dun sa R? Si R is called as our radius of curvature. Okay? Ayan. So, mula doon sa ds is equals to R d theta, ano yung makukuha natin? Kasi kailangan natin, again, ibalik na kailangan natin ng representation ng theta in terms ni M. Kasi yun yung kaya natin i-solve, di ba? So, when we try to rearrange yung ds equals to R d theta, what will happen? We will have a value na pwedeng gawin natin na d theta over ds is equals to 1 over R. Okay? And dito, based from our observation, si ds is equal to ds. Okay? So, we can rewrite na d theta is equals to dx is equals to 1 over R. Meaning, the change in theta in terms of x equals to 1 over R, yung reciprocal ng radius of curvature natin. Then we can perform na d theta is equals to 1 over R dx. And then we integrate both sides. We will have another value for theta, which is equals to integral of 1 over R dx. Okay? So, ayan, meron tayong value for theta, pero it's still not in terms of x. In terms of R pa din siya. Okay? So, yun yung dilemma natin for today. No? Ang kailangan natin, based from our previous slide, is si theta maging in terms ni x, pero si theta, na-representa natin siya in terms ni r. Kaya kuha tayo ulit ng relationship based from our figure. So, based from our figure, okay, so dito, exaggerate natin yung drawing. Okay, so limbawa ito yung ating mismong drawing, no? Ito yung ating neutral axis. And then, pag nag-pass through tayo ng line dito, okay, makikita natin na mula doon sa neutral axis natin, okay, meron tayo ditong na-form. Okay, itong portion na to. Itong portion na to, let's say, ito na lang para kita natin. Okay? Yung portion na yon is nasa tension side tayo, nag-lengthen siya. So, ibig sabihin, may change in length siya. So, yung change in length na yon pwede natin i-represent as sigma or as epsilon or strain. Okay? O yung elongation natin. Tapos yung distance from the neutral axis, pwede nating tawagin na y. Okay? And then yung create niyang angle doon is equals kay theta also. Okay? So that is equals also sa theta. Okay? So, pwede nating ilabas, no? Halimbawa yung ito yung nakuha natin na value dun sa portion na yon. And when we look at it, we will have also a tangent of theta is equals to strain over yung y natin, or theta is equals to strain over y. Okay? So based from this value, we can go back to sa strength of materials natin and see if we can substitute any values mula dito sa nakuha nating value ni theta. And we can see na si strain, pag tinignan natin yung equation for Young's modulus, yung modulus of elasticity, that is the ratio of our stress over strain do sa stress and strain diagram natin. Okay? So, ibig sabihin, si strain or si Young's modulus, pwede natin siyang i-represent as strain is equals to stress over modulus of elasticity. Okay? So, let's do that. So, we have theta is equals to strain over y. And then substitute natin sigma over E and Y. Okay? And then, when we get yung stress in yung flexure, stress natin in flexure or yung bending stress natin, meron siyang value na my over I. So when we substitute that here, we will have my over I E times Y. Then we can see na we can eliminate y. So we have theta is equals to m over ei. Okay? So may nakuha tayong value ni theta na m ei. Okay? Pero based from our previous slide, anong meaning ng ating theta? So based from our previous slide, si theta natin ay equal sa 1 over r. So we can say na si m over ei equals siya sa 1 over r. So based from the formula na 1 over r dx, we can say na si theta o yung slope natin is equal sa m over ei dx. So ito yung ating slope equation. Okay? And then based from our derivation do sa first slide, ito, v integral of theta dx. So yung v is equals to integral of theta dx, we can substitute yung theta natin as integral of ei dx squared. Okay? Kasi nagkameron ng dalawang dx. So, dito lalabas kung bakit nagkameron ng double integration method. Okay? Because of the double integral sign dito to get yung ating deflection. Okay? So, this particular formula is for our slope and this is our deflection. Okay? In some textbook, iba lang yung representation, no? Si slope can be represented as yung first integral natin, yung first derivative natin, no? So, minsan, nakalagay sa kanya is yung first derivative nung yung ating v can be represented as o yung pinaka main equation natin can be represented as ei v double prime is equals to m ei. Okay? Then when we integrate that or when we derive that, makukuha natin yung slope, that is ei vi, and then we have our m ei dx. Yan yung slope natin. Then when we try to integrate pa ulit another one, sorry, wala na palang ei doon sa loob, no? Kasi nandoon na siya sa kabilang side. Ilagay lang natin doon sa kabilang side. Okay? And then okay, yan yung slope natin. And then yung isang representation niya is eiv equals to double integration ng mdx. Okay? So ito is same representation lang din ito. And ito is same representation ito. Okay? So that is the conversion how we conclude or we arrive with the double integration method. Okay? And to demonstrate this, or how to use this, we use it on an arbitrary beam muna, no? So, ibig sabihin, wala muna tayong values ng beam para mas maintindihan natin. O, wala muna tayong physical values. Lahat tayo ay variable lang muna. So, let us consider itong ating simply supported beam loaded ng P sa gitna niya. So, we are asked to find kung ano yung magiging maximum deflection natin. And upon qualitative observation or by inspection, alam natin na since yung loading natin is sa gitna, yung elastic curve natin is ganyan yung magiging itsura. So, ayan. So, ang i-assume natin, pwede natin sigurong sabihin na yung maximum Y natin, yung deflection natin, yung Vmax natin, is makukuha natin doon sa gitna. Okay? So, ayan. So paano natin makukuha yung equation natin? So, kailangan natin consider is, nung una, yung moment function natin, by segment tayo nag-consider, di ba? Ibig sabihin, kung saan may loading, dito, ano yung mga loading natin? Magkakameron tayo ng reactions dito. Let's say ito si A, ito si B. Ito meron tayong reaction at A, then reaction at B. No? And then, ginagawa natin, magkaka tayo ng section dito sa section na to get yung internal moment dun sa portion na yun. And then another section to get yung internal moment para dito sa distance na to. In doing double integration method, proceed ka na kaagad dun sa masasakop lahat yung loadings natin. So, yung cut ng section natin will be on the last segment na. Okay? So, let us consider itong segment na to. Okay? So, considering that segment, so, ano muna yung RA and RB natin? So, since this is simply supported lang, siguro you would agree na P over 2 lang both yung value natin. Okay? So, ito yung ating free body diagram. Okay? Ito yung cut natin. Ito yung ating reaction na P over 2. And then ito yung A natin. And then si P natin somewhere dito. So, yung distance na to is L over 2. Then, alam natin na pag ito, inassume natin na si X, we will have a distance of X minus L over 2. And ito yung point O natin. Wherein, dito natin kukunin yung moment function natin. Okay? And then, we try to get yung moment function natin. Okay? So, summation of moment at O is equals to 0, taking counterclockwise as positive. So, we have M plus P times X minus L over 2 plus minus P over 2 times X is equals to 0. So we will have a value of moment na P over 2 X minus P times X minus L over 2. Okay. So in doing double integration method, once you are considering a moment from different segment, hindi nyo siya pwedeng i-simplify na later de-define natin. And as you can see here, imbis na parenthesis yung gamitin natin, ang ginamit ko is this symbol, no? That is to indicate na itong symbol na to, itong particular term na to, is para lang dun sa segment na ito. Yung from the half of the segment hanggang dun sa full segment natin. Later, didiscuss natin more in detail yan. Okay? Pero ngayon, nakuha na natin si moment in terms ng ng X. Okay? So, we can use now our formula for our yung formula natin, no? So, EI B double prime is equals to yung M natin is P over 2X minus P times X minus L over 2. Okay? So to get our slope, i-integrate natin both sides. So kakameron lang tayo ng dx dito. So we have EIV. Okay, si EI is given, usually given siya sa problem. That is the modulus of elasticity E, and then CI is yung moment of inertia natin, cross section. Okay, single prime is equals to So integrate mo lang to, we will have p over 2 x squared over 2 minus p x l over 2 squared over 2 plus, since nag-integrate tayo, meron tayong integration constant na C1. Okay? So ito yung sa slope natin. Next is to integrate again our equation. We will have EI V. So this will be our deflection now. Maybe kailangan muna natin i-simplify muna yung equation natin sa taas. No? So we will have EIV prime is equals to P over 4 x squared minus P over 2 x minus L over 2 squared plus C1. So this is our slope equation. Okay. Next is our deflection equation. So integrate lang natin. E I B is equals to ini-integrate ko, no, hindi ko lang nalagyan ng symbol. X cube over 3 minus P over 2 x minus L over 2. This is 3 over 3 plus C1x, and then meron tayong another constant of integration which is C2. Okay? Then simplify natin, we will have an equation EIV is equals to P over 12 x cube minus P over 6 x minus L over 2 cube plus C1x plus C2. And this will be our deflection equation. Okay? Ayan. So once meron na tayo niyan, we cannot use yung equation muna as is, no? We need to solve muna what will be the value of our C1 and C2, yung arbitrary constant natin. And when we can get those value using yung tinatawag nating boundary conditions. Okay? The boundary conditions are dependent kay supports natin. So ibig sabihin, ano bang nangyayari dun sa mga support natin? Ano yung deflection sa support natin? So we have here a hinge and a roller. And alam natin na ang reaction ng hinge natin is a vertical tsaka horizontal. Ang roller natin is a vertical. So ano ibig sabihin? Kung meron tayong reaction in the vertical direction, hindi natin inaalaw na magkameron ng change in value nung y direction natin. So ibig sabihin wala tayong deflection at support. As we can observe din doon sa elastic curve natin, nandun siya ulit sa 0 point niya. So we can say na at x is equals to 0 or yung sa leftmost or yung sa support A natin, ang deflection natin doon ay 0. Okay? So yun yung first natin. Next is ano mangyayari kapag ganun yung condition natin? Try natin substitute to sa deflection equation natin. Kung 0 si V, so ito magiging 0. Okay? Magiging 0 to. And then lahat itong equation natin na may multiply ng x, okay, will be 0. Dito sa term na to, pag nag-negative yung terms inside nung gantong symbol, you have to neglect it. Kasi pag nag-negative siya, ibig sabihin, hindi siya kasama doon sa segment na kino-consider natin. Okay? So dito maging 0, 0, 0. So matitira is C2 lang. So we have shown na si C2 will be equals to 0 kapag yung boundary condition natin is ito. Okay? Yung second boundary condition natin, kapag yung x natin ay equal sa L o sa full length natin, yung v din natin ay equal sa 0. So, gamitin natin ulit yun. So, yung EI, v natin will be 0. This will be P over 12. And then, this will be L cubed. Okay? Minus P over 6. Substitute natin, L minus L over 2. Cube. Plus, C1 natin, yun yung unknown. And then, X times L. C2 natin is 0 na, no? So, simplify natin to. We have 0 is equals to PL cube over 12. And then ito will be L minus L over 2 is L over 2. So magiging P L cube over 2 cube is 8 times 6. So ilan yun? So 2 cube is 8 times mo ng 6, that is 48. Okay? Pero this is minus pa din over 48 plus C1L. Okay? Then let us solve for the value of C1. So ito pwede natin ito pag-combine na kasi PL cube siya parehas, no? So C1 natin will be equals to 1 over 12 minus 1 over 48. That is 1 over 16. So negative PL squared over 16. This is our value ng C1. Okay? So, yung equations natin, yung slope and deflection equations natin, we can rewrite it now as a full equation na wala na tayong arbitrary equation. Okay? So, for our slope muna, okay? For our slope, our equation will be EI, V prime, is equals to P over 4, x squared, minus P over 2, x minus L over 2 squared. And then kung ano yung value ng C1, negative PL squared over 16. So ito yung ating slope equation. For our deflection equation, we have EIV is equals to P over 12 x cubed minus P over 6 x minus L over 2 cube minus PL squared over 16 x. So this will be our deflection equation. So itong dalawang to, this will be our representative equation for the slope and deflection at any point dun sa mismong beam natin. So ibig sabihin, kahit anong point yung kunin nyo dito, basta substitute nyo dito sa equation na to, makukuha mo yung slope and deflection natin. Okay? So kapag halimbawa, pinapanap sa atin yung maximum deflection na lang. Okay? So what will be our maximum deflection? So copy lang natin to equation natin for deflection. Okay? And then nakita natin dito, alam natin na yung maximum deflection natin is located dun sa center natin kasi dapat siya yung dito kasi concentrated. Pero pag halimbawa hindi natin alam kung saan yung location ng maximum deflection natin, ang gagawin niyo is kukunin niyo yung slope equation and then i-equate niyo siya sa 0. Kasi ano ba yung slope natin at dito? Diba yung slope natin diyan, pag nag-pass through tayo ng line, should be equal sa 0. So, equate mo to sa 0, so makukuha mo yung value ng x. Okay? So, pakita natin ngayon yung maximum deflection natin. So, for this problem, assume natin nasa gitna yung at x is equals to L over 2, yun dun yung ating Vmax. Okay? So, using our equation, and the equation natin. So, Vmax natin. So, Vmax is equals to, pwede natin i-divide si EI. And nasasubstitute natin si L over 2 sa lahat ng may x. So, P over 12, L over 2, cube, minus P over 6, L over 2, minus L over 2, cube, minus P, L squared over 16 times L over 2. Okay? Dito, this will be 0 kasi L over 2 minus L over 2 is 0. Then, simplify natin yung remaining. 1 over EI. This will be P, L cube. And then 2 cube is 8 times 12. That is 96. Okay? Minus, this is P, L cube. So, 16 times 2 is 32. Okay? If we simplify, Vmax is equals to 1 over EI times 1 over 96 minus 1 over 32. We have negative PL cube over 48. And when we simplify this, we have negative PL cube over 48 EI. This will be our equation for maximum deflection for a concentrated load at midspan. Okay? So, negative indicate na below nung ating elastic curve o yung below dun sa origin natin, below ito yung value niya. Okay? So, ayan po yung ating maximum deflection. And then in this formula, actually, you can use this formula right away. Kung halimbawa ang given mo is a concentrated load at midspan lang, then pinapahanap yung maximum deflection, you can just substitute yung value mo ng P, ng L, and then ng E and I para makuha mo yung maximum deflection. Okay? So, ganyan po natin dinederive yung deflection and slope equation natin. Na basically, we perform this over and over again on different beam conditions. So pag nagbago yung beam condition natin, definitely the deflection and slope will be different kasi yung elastic curve natin will be different. So yung method natin will be performing everything from the start. Okay? As long as you understand how the equations are formulated, I'm sure you will not have difficulty in arriving with the slope and deflection equation. Okay? So let us try this example sa numerical example naman, no? So that we can appreciate. Okay? So ayan. So before we go dun sa example natin, we need to define the following. First is yung explicitly defined terms na tinatawag natin. Notice in our equations on the previous slide na meron tayong enclosed with angle brackets. Ito yung sinasabi ko kanina instead of yung usual parenthesis natin. Ang ini-imply nun is each term na merong angle bracket is a value for a particular segment lang na kapag daw naging negative yung value natin, we neglect yung term na yon in the computation. Okay? So, as same as this one, no? So, halimbawa, maging value natin is L over 4. So, si L over 4 nandito. Pag sinubstitute mo si L over 4 dito, minus L over 2, ang makukuha natin is a negative quantity, which is negative L over 4. Once na nag-negative yung quantity mo inside ng angle bracket, you will consider na 0 na siya kasi that particular force is not contributing dun sa segment na yon. Kasi dito, pag kinagkat tayo ng section na yan, wala naman si P doon, no? Si P is nandito lang, may effect lang siya mula dito sa point na to hanggang sa point na to. Kaya kapag nag-negative yung quantity natin inside the angle bracket, we neglect yung value niya. Okay? Next, yung boundary conditions natin. With the general moment equation, we only have two unknown quantities dahil sa integration natin, which are yung constant integration constant natin na C1 and C2. And to get those value, sabi natin kanina, we use yung boundary conditions. And these boundary conditions deal with the restriction of the deflected shape with regards to the support. So ito, nilagay ko na lang din dito, no? For a roller, yung vertical translation natin, so ibig sabihin yung up and down na movement natin is not allowed, kaya yung change in the vertical direction is 0. Okay? For a hinge, wala tayong vertical and horizontal movement, so kaya yung vertical natin is 0 and yung horizontal natin is also 0. For a fixed support, alam natin na meron tayong tatlong reaction. We have a vertical, a horizontal, tsaka a moment. Kaya yung vertical movement natin is restrained or wala. Yung ating horizontal movement is wala. And of course, yung rotation natin, yung slope natin due to moment dun sa fixed support natin ay equal sa 0. Okay? So, you have to go back to this na lang if you want to set yung boundary condition nyo for your problem. Okay? So, let's have our first numerical example. So, a simple supported beam 10 meters in length with a uniformly distributed 100 Newton per meter. Okay? So, ang pinapahanap is find the slope and deflection at midspan. So, when we try to assume what will be our elastic curve, so since this is a uniformly distributed load along the entire length, pwede natin i-assume na yung elastic curve natin will be the same as the previous one. Wherein yung midspan natin is yung ating greatest deflection o yung maximum deflection natin. Okay? So, what to do is to perform yung ating analysis, no? So, you have to identify first yung ating support reaction. Okay? And then, we know na yung uniformly distributed load is, anong meron sa kanya? Meron siyang equivalent na concentrated load na equals dun sa area niya, that is 100 Newton per meter, times yung 10 meters natin, that is equals to 1,000 Newton. Okay? So, kung nasa gitna naka-apply yun, we can say na si RA and si RB are, ano yung sinusuportahan nila? So, they are supporting the same weight, no? So, we can say na magtutulungan sila kasi nasa gitna lang yung support, nasa 5 meters. So, we have 500 newtons dito sa RA and 500 newtons kay RB. Okay? And then, since isa lang yung loading natin, we can select any location, no? So, drawing our free body diagram. So, this is our cut section, any part. And then this is our RA, which is 500 newtons. So, arbitrary to. So, kaya X natin i-assume. And then, yung ating uniformly distributed load is 100 newton per meter. So, ano yung magiging ECL niya ngayon? So, that is 100 Newton per meter X. Okay? Then, yung distance niya is X over 2. Okay? So, kung kailangan natin ng moment at this point, so that is moment. So, kailangan natin yung equation na yan. So, summation of moment at O is equals to 0, taking counterclockwise as positive. We have M plus 100 Newton per meter X times yung distance natin na X over 2 minus yung 500 Newton times X natin equals to 0. So yung moment natin is equals to negative, let's say 50 Newton per meter X squared plus 500 Newton X. Okay? So this will be our moment equation or moment function. So going back to our main equation, EI V double prime is equals to M. Okay? So, hindi sinabi yung value ng EI dito, no? So, assume na lang natin na constant lang yung EI. So, EI double prime, maybe dito ko na nalagay para save tayo ng space. So, yung moment natin is negative 50 Newton per meter X squared plus 500 Newton times X. Okay? So, integrate natin. So, we have EIV prime is equals to first integration natin, negative 50 Newton per meter X cube over 3 plus 500 Newton X squared over 2 plus C1. Okay? Simplify natin, we have negative 50 over 3 Newton per meter X cube plus 250 Newton X squared. Okay? Plus C1. Then integrate ulit natin to. So ito, lagyan ko lang ng integration, no, para hindi tayo nalilito. So integrate ulit natin to. This will be EI V. So this is our slope equation agad, no? So yun yung first derivative natin. Okay, first derivative or first integration natin. Then yung sa deflection natin will be negative 50 over 3 Newton per meter x to the 4th over 4 plus 250 newtons x cube over 3 plus C1x plus C2. Okay? Simplify lang natin. We have EIV is equals to negative 50 over 12 Newton per meter x to the 4th plus 250 over 3 Newton x cube plus C1x plus C2. Okay? So, ito yung ating deflection equation. Okay? Pero to continue with our solution, we need to get our boundary condition. Okay? So, sa support tayo, yung support natin is hinge tayo sa left side. So, at x is equals to 0, ang v natin is equals to 0. So, pag sinubstitute natin si v is equals to 0 dito, so magiging 0 to. And then si x, so 0 lahat to. So matitira ay C2. C2 is equals to 0. So pwede na sabihin C2. Baguhin natin yung sulat. No? Gawin natin. X is equals to 0. B is equals to 0. So C2 is equals to 0. Yan yung first boundary condition natin. Okay? Next. Yung second condition, boundary natin is X is equals to L. So B is equals to 0. So ano mangyayari? So substitute natin dito yung 0 na B and then si L dito. So we have 0 is equals to negative 50 over 12 Newton per meter L to the fourth plus 250 over 3 Newton L cube, okay, plus C1 L. Okay? Okay. So dito yung L natin na equal sa 10 meters. Lagyan natin ng value, no? So rewrite ko lang ulit to. So gawin natin tong negative 50 over 12 para ma-combine natin, no? Baka kasi hindi ma-combine. 10 meters to the fourth plus 250 over 3 Newton, 10 meters cube plus C1 times 10 meters. Okay? So pag sinolve niyo yung C1, magko-combine tong dalawa kasi parehas sila magiging Newton meter cube, no? Kasi magka-cancel yung isang meter dito. So negative 50 over 12 times 10 to the fourth plus 250 over 3 times 10 cube. Okay, then transpose niyo yun and then divide nyo by 10. May makukuha tayong value na 1, negative 1,000 at 12,500 over 3 or equal siya sa 4166.67 negative. Okay? So yan yung value ng C1 and C2 natin. Okay? So what will be our equations now? Our equations will be, i-write ko lang muna dito. E1 B prime, yung slope natin, will be equal sa negative 50 over 3 Newton per meter x cube plus 250 Newton x squared minus 12,500 over 3. So ito yung sa slope natin. Okay? So let me copy lang that para i-transfer natin sa another slide. No? And so ito yung ating sa slope. Yan yung gagamitin natin. And then for our deflection, we will have EIV is equals to negative 50 over 3 Newton meter x to the fourth plus 250 over 3 Newton x cube minus 12,500 over 3 x. Then C2 natin is 0. So this will be our solution na for our equation natin for our deflection. Okay, and then let's transfer that here. Yeah. So ito na yung equation natin, slope and our deflection equation. Ang tanong sa problem, find the slope at midspan. Ang midspan natin is, ibig sabihin, gitna, no? So kung 10 ang total natin, ang kailangan natin is at 5 meters, no? So at 5 meters, at x is equals to 5 meters, pinapahanap sa atin yung value ng slope and yung value ng ating deflection. Okay, yung sa slope muna, substitute natin. EI, VI is equals to negative 50 over 3 Newton per meter times 5 meters cube plus 250 Newtons, 5 meters squared minus 12,500 over 3. So EI, V prime natin is equals to negative 50 over 3 times 5 cube plus 250 times 5 squared minus 12,500 over 3. Our answer is 0. So, ibig sabihin ng slope at 5 meters ay equals to 0, meaning, yung kinukuha pala nating B, no, ay equal sa our maximum deflection. Okay? Sabihin, kapag slope natin is equals to 0, siya yung ating location of um, max deflection. Okay? Max or mean, no? Depende kung pataas o pababa, no? Kaya max or mean. Pero dito, for simplicity, max deflection natin. Okay? So, next is, ito yung answer natin for number 1, for the first question, a slope. Okay? Next is para dun sa as equals to 5 meters, kung ano yung value ng V natin, V lang, no? So, gamitin natin yung second equation. Ito yung first equation, second equation. Okay? So, second equation, EIV is equals to negative 50 over 3 Newton per meter times yung x natin is 5 meters to the fourth plus 250 over 3 Newton 5 meters to cube minus 1 to 500 over 3 times 5 meters. Okay? So, yung 12,500, ano yung unit niya? Again, mula dito sa previous slide, ang unit niya is Newton meter squared. Okay? Kasi pag transpose, magde-divide ng meter. Okay? Newton meter squared. So, this is Newton meter squared. So, lahat sila is magiging in terms ng Newton meter cube. So, pwede natin siyang pagsama-samahin, no? Newton meter cube. Okay? So, negative 50 over 3 times 5 to the fourth plus 250 over 3 times 5 cube minus 12,500 over 3 times 5 meters. That is equals to negative 62,500 over 3 Newton meter cube. So, magkano yun sa value? We have a value of negative 20,833.33 Newton meter cube over EI. Yan yung value ng deflection natin. So, this will be our answer. So, nagkataon na wala tayong value ni EI, no? So, kung halimbawa magkameron tayo ng value ni EI, what will be our value ng deflection? Okay? So, lagyan natin ng value. So, halimbawa gawin natin si E ay equal sa 200 times 10 to the 3 Newton per mm squared. Okay? And then, try natin si inertia ay equal sa 60 times 10 to the 6 mm to the 4th. Okay? Ano yung magiging value natin? So, V is equals to, yung buo yung ilalagay ko, no? So, ito is naka-Newton meter siya, Newton meter cube, iti-change ko sa mm para, ano tayo, uniform tayo sa unit. Then, this will be 200 times 10 cube, Newton per mm squared, times 60 times 10 to the 6 mm to the 4. Okay? Mangyayari si Newton magka-cancel out. Si mm squared magka-cancel out dito. May matilang mm squared doon. So, dito, magiging mm cube siya. May mm squared sa ilalim. So, makaka-cancel yung mm squared. Matitira is mm lang. So, yung value ng deflection natin is negative 62,500 over 3 times yung 1,000 cube natin all over 200 times 10 to the 3 times 60 times 10 to the 6, we will have a deflection of negative 1.736 mm. So, ito yung possible deflection natin if yung value ng E at ang I natin is ito. Okay? So, ganun po natin ginagamit yung equation na yan. Okay? But to answer this problem, our deflection at midspan will be this equation, and then our slope at midspan, since this is a maximum deflection, is equals to 0. Okay? Alright, so next. We try another one. So ibang condition naman, we have a fixed a fixed beam or cantilever beam, no? So ibig sabihin, fixed at one end and free at one end. So we have a concentrated load at center, 25 kilonewton. And then, ayan, ito yung mga question natin. Given yung value ng E natin is 200,000 megapascal. Si megapascal is also equal sa Newton per mm squared. Okay? Yung pinapahanap is yung slope at free end. So, ibig sabihin, slope at C. Yung slope at C. Deflection at free end. So, deflection at C. Tsaka deflection at midspan. So, deflection at P. Right? So, yan. So, the action natin is upward since this is a fix, no? Sorry. So, RAV, RAH, tsaka yung moment natin na MA. Okay? So, yung values niyan, so this will be 25 kilonewton lang and then yung moment natin is moment lang natin yung 25 times 6, that is 150 kilonewton meter. Okay? So, para ma-consider natin yung lahat ng loading doon sa member, magkakatay ng section is dito sa section na to. Okay? So, our free body diagram, ito yung cut section natin, ito yung point O doon sa cut. So, our dito is 25 kilonewton. Then we have a moment of 150 kilonewton meter. Then a concentrated load of 25 kilonewton at center. And then kung ito ay X, okay, and ito ay 6 meters, so this is X minus 6. Okay? Kunin natin yung moment at O, yun yung ating moment function. So summation of moment at O is equals to 0. Taking counterclockwise as positive, so we have M plus 25 kilonewton multiplied by X minus 6 minus 25. So meron pa pala tayo isang moment, no? Meron pa tayong 150 kilonewton. So lagyan natin yan later. Kilonewton times X. And then we have a counterclockwise then. So for 150 kilonewton meter is equals to 0. Okay? So yung moment natin, equation natin, will be equals to negative 25 kilonewton X minus 6 minus 25 kilonewton times X, plus na pala to, and minus 150 kilonewton meter. Okay, so yan yung moment function natin. Using our equation, EIV double prime is equals to M. So substitute natin, negative 25 kilonewton X minus 6 plus 25 kilonewton X minus 150 kilonewton meter. So practice including the units na lang para later sa conversion hindi tayo na lilito, no? So we can integrate na this one. So we have EI V prime is equals to negative 25 kilonewton X minus 6 squared over 2 plus 25 kilonewton X squared over 2 minus 150 kilonewton meter X plus C1. Okay? Simplify natin. So, EI V prime, that is negative 25 kilonewton over 2 X minus 6 squared plus 25 over 2 kilonewton X squared minus 150 kilonewton meter X plus C1. Okay? Then, integrate natin. Split. We have EI V is equals to negative 25 kilonewton over 2 times X minus 6 cube over 3 plus 25 over 2 kilonewton X cube over 3 minus 150 kilonewton meter X squared over 2 plus C1X plus C2. So simplify lang natin. EIV is equals to negative 25 kilonewton over 4 X minus 6 cube plus 25 kilonewton over 6 X cube minus 75 kilonewton meter X squared plus C1X plus C2. So yun yung ating deflection equation. So next is to get our boundary condition. Okay? So kapag si x ay equals to 0, anong meron? Wala tayong v is equals to 0. Okay? So pag sinubstitute natin yun dito, this will be 0. And then ito, pag sinubstitute natin yung 0, it will be negative quantity. So 0 na din. 0, 0, 0. So C2 natin ay equals kay 0. Okay? Ano pang meron tayo? So wala tayong support dun sa end. So pag x is equals to 0, ano pa yung wala natin? Rotation ay equals sa 0. Or yung symbol natin for rotation, v prime equals sa 0. So ito din yung ating theta, no? So, ibig sabihin yung dito tayo sa theta ngayon, kukuha ng equation. So, pag 0 yon, ano mangyayari? 0 to, then ito will be negative. So, 0 na to, 0, 0. So, si C1 natin will be equals to 0. Okay? So, mas madali yung ating equation ngayon. No? So, lagay natin yung sa slope. Yung slope natin, EI V prime is equals to negative 25 over 2 kilonewton x minus 6 squared plus 25 over 2 kilonewton x squared minus 150 kilonewton meter times x. Then you see ano is 0 kaya wala na yan. So ito yung ating slope equation. Nalagay na lang natin sa next slide. Yan. Ito yung slope. Next is yung ating deflection. So EIV is equals to negative 25 over 4 kilonewton. Then x minus 6 cube plus 25 kilonewton over 6 x cube minus 75 kilonewton meter x squared. And then si C1 will be 0, Z2 is 0. So ito lang yung values natin. Okay, so this will be our deflection equation. Yan, so ito yung ating equation 1 and equation 2. Alright? Yan, so pwede tayo magsagot kasi meron tayong general equation for slope and deflection. So, sagutin lang natin yung first one. At A, slope at free end, so at x equals to 12 meters, ano daw yung ating V prime? So, substitute lang natin. Meron tayong value ng EI. So, V prime equals to negative 25 over 2 kilonewton times 12 meters minus 6. So, yung 6 na yun, 6 meters, syempre, no? Squared plus 25 over 2 kilonewton, 12 meters squared minus 150 kilonewton meter times 12 meters. Okay? And then over, let me adjust this one. Okay? Yung EI natin is 200 times 10 cube Newton per mm squared times yung I natin na 60 times 10 to the 6 mm to the 4th. Okay? Yung numerator natin, pag naging answer natin, magiging unit niya is kilonewton meter squared, no? Okay? So, kailangan convert natin yan into newton tsaka mm. So, yung kilonewton muna. So, that will be 1 kilonewton is 1,000 newton. And then, multiply natin ng 1 meter, 1,000 mm para maging mm squared. Okay? So, performing that, we will have Newton mm squared sa numerator, and then sa denominator, we will have, magka-cancel out to, matitira, Newton mm squared. So, magka-cancel out parehas. So, we will have a value lang na wala, no? So, unitless, so radian yung tawag sa kanya. Okay? So, perform lang natin, negative 25 over 2 times 12 minus 6 squared plus 25 over 2 times 12 squared minus 150 times 12 times yung 1,000 natin sa kilonewton, then 1,000 squared divided by 200 times 10 to the 3 times 60 times 10 to the 6. we will have negative 0.15 radians. Negative 0.15 radians as our rotation sa kanya. Okay? So, anong ibig sabihin niya? So, di ba yung elastic curve natin dito will be like this, no? Okay? And then yung slope na yon is kung ito yung point na yon, magpa-pass through tayo ng tangent line and then yung kanyang sa horizontal, ayan, yung na-create niyang theta is ito, no? Counterclockwise siya, kaya siya ay negative. Negative yung value niya, which is correct dito. Okay? Right? So, ito yung answer natin for the first one. Okay? Next, deflection at free end. So, deflection tayo. So, yung formula natin is B. So, negative 24 kilonewton and then 12 minus 6, 3 plus 25 over 6 kilonewton. 12 cube minus 75 kilonewton meter. 12 squared. So, yung unit natin dito will be kilonewton mm cube. So, kailangan natin mag-multiply ng 1,000 para sa kilonewton and then 1,000 cube para dun sa mm. Okay? Over 200 times 10 to the 3 newton per mm. Then, this will be 60 times 10 to the 6 mm to the 4th. Okay? So, matitira is sa numerator, may matitira tayong Newton mm cube. Then sa ilalim is Newton mm squared. So, cancel yung Newton mm squared. So, mm ang matitira. So, yung value ng V natin dito is negative 25 over 4 times 12 minus 6 cube plus 25 over 6 12 cube plus minus 75 and then 12 squared. Okay. Then ito, times 1,000 times 1,000 raised to 3. Okay. Over 200 times 10 to the 3 times 60 times 10 to the 6. Okay. Let me check nga lang yung V prime natin. Dapat ito, parang may mistake ako, no? Dapat yung itong dalawang quantity to, i-multiply natin dun sa kabuuan ng ating equation. Kasi baka doon ko lang sa isa na multiply. Let me check. 25 over 2, 12 minus 6 squared plus 25 over 2 and 12 squared minus 150 times 12 equals. Tapos tsaka natin go convert into 1,000 plus 1,000 squared all over 200 times 10 to the 3 plus 60 times 10 to the 6. Ayan. So, may mali nga tayo sa value, no? So, let me check yung value. So, the correct value is negative 0.0375 radians. Okay? So, ayan. So, ito yung answer natin for the letter A. Okay? Next is negative 24 over 4. Doon sa deflection na tayo ulit. Times 12 minus 6 cube. Okay? Plus 25 over 6 times 12 cube. Minus 75 times 12 squared. Okay, equals. Tapos, multiply natin ng 1,000 plus 1,000 raised to 3. Tapos, tsaka natin divide by 200 times 10 to the 3 times 60 times 10 to the 6. Yan. Our answer for this one is 25 over 6. Let me check nga ulit to. 25 over 4. Ayan. So, this is 3, no? So, may mistake ako dito. This should be 3. So, dapat ito ay 6. So, yan. Yan yung pwedeng maging very crucial sa atin, no? Pag namali tayo ng sulat. So this should be 6. So let me do that again. So 25 over 6. So times 1,000 to the fourth. Plus divide natin by 200 times 10 to the 3 times 60 times to the 6. Ayan. So we will have negative 375 mm as our deflection dun sa free end natin. Okay? Next, letter C. Deflection at midspan. So at midspan, x is equals to 6 meters. Okay? So ano mangyayari? Ito yung deflection equation natin. Pag 6 meters ginamit natin, dito magiging 0 siya. So cancel na to. Okay? So ang sa-substitute na lang natin is dito sa dalawang term na lang. Okay? So V natin doon will be 25 over 6 times 6 cube minus 75 times 6 squared. Tapos multiply natin to by 1,000 to the fourth. Over 200 times 10 to the 3 times 60 times 10 to the 6. Okay, so ano yung magiging value ng V? So 25 times 6 cube all over 6 minus 75 times 6 squared. Tapos tsaka natin multiply ng 1,000 raised to 4 divided by 200 times 10 to the 3 tsaka 60 times 10 to the 6. We will have a value of negative 150 mm. Okay, so this will be our answer for this problem. Okay, so as we can see, mula doon sa elastic curve natin, at this point, ito yung maximum deflection natin, which is evident kung saan nakuha natin yung value na 375 mm yung value niya. And at the center, 150 lang siya. So meaning 150 mm to, then 375 to. Okay, so that is our second example. Right? So for the third example, I will let you calculate this one. Ang gagawin ko lang is I will get yung moment equation and I will let you continue the solution. So for this question, determine daw natin yung moment of inertia I of the beam when the deflection at midspan is L over 360. So ibig sabihin at x is equals to 5 meters, ang deflection daw natin is kung ano yung L over 360. So, L natin, so dapat in mm over 360. So, dapat deflection daw natin is 10,000 over 360. So, yung value natin nakuha is, since that is a deflection, negative dapat 250 over 9 or equal sa negative 27.78. Ito yung first condition natin. Second is, identify daw natin yung Vmax natin. Yun yung pinapahanap. Okay? So, here, kailangan natin i-calculate yung ating support reactions. So, we have our RA, and then RB dito. Then, for a triangular section, meron tayo dito na 1/2 times 55 times 10. No? So, value natin is, that is how much? 275. So 275 newtons. Okay? Yung distance niya is 2 over 3 dito. So 2 over 3 ng 10, that is 20 over 3. Okay? So performing yung ating summation of moment at A is equals, gawin natin at B na lang para kuha agad natin si RA. Kasi yun yung kailangan natin. So yung distance natin is 1/3 nung ano natin. So 1/3 ng length natin, which is 10. So that is 10 over 3. So summation of moment at B equals to 0, taking counterclockwise as positive. We have yung ECL natin at 275 newtons times 10 over 3 meters is equals to 10 equals to RA times 10 meters. So ang RA natin is equals to 275. So dito cancel yung 10 meters, so 275 over 3 newtons yung value niya. Okay? So, pag kinat natin yung section, okay, pag nagka tayo ng section, ang mangyayari sa triangle natin, kailangan natin kunin yung representative value ni y. Okay, ito yung 55 natin, ito yung y, ito yung x. So, kailangan natin kunin yung relationship niya. So, y over x is equals to 55 over 10, or y is equals to 5.5 Newton per meter x. Okay? So, pag kinuha natin yung free body diagram natin, okay, ito yung loading natin. And ang quantity nito is yung y natin equals sa 5.5 Newton per meter x. Okay? Yung ating reaction is 275 over 3 Newton. This will be x. So, yung ating ECL will be 1/2. Ito yung ECL natin. So, 1/2. Dito ko na lang lagay. 1/2 nung ating 5.5 Newton per meter x times yung ating x. So, this will be 5.5 over 2. So, 2.75 Newton per meter x squared. So, 2.75 Newton per meter x squared. Tapos, x over 3 yung distance niya dito. So, kailangan natin yung moment at point O. Yun yung ating equation. Okay? So, summation of moment at O is equals to 0. Taking counterclockwise as positive. We have M plus yung ating 2.75 Newton meter x squared times x over 3 minus 275 over 3 Newton times x is equals to 0. So, yung moment equation natin will be equals to 2.75 divided 3, that is 11 over 12. So, negative 11 over 12 Newton meter x cubed plus 275 over 3 Newton x. Okay? So, this will be our moment equation. So, ang gagawin ninyo, substitute na lang dito to get yung ating value for slope and then for our deflection. So, paano masagutin yung first one, yung moment of inertia? Yung moment of inertia natin, masasolve siya since given yung ating deflection at center. So, gagamitin nyo lang yung V is equals dito. So, magiging unknown natin is yung I natin. So, halimbawa, gamitin natin na kasama natin sa given na E is equals to um, sabi natin 8 times 10 to the 3 Newton per mm. Yan. So, yun yung gamitin natin. So, makukuha natin yung value ni I. Then, pag nakuha natin yung value ni I, yun yung gagamitin natin para kunin yung maximum deflection. So, paano ma-identify kung nasa yung maximum deflection? Kailangan equate natin sa 0 si V prime. Okay? Pag in-equate natin sa 0, may makukuha tayong value ni x. So, ito yung location ng maximum deflection. Then, kung ano yung makuha natin yung value ng x, yun yung gagamitin natin dun sa equation ng V natin. Okay? So, for checking, our answer, or your answer should be, yung inertia, ang value niya should be 16.11 times 10 to the 6 mm to the 4th. And yung kailangan maging value niya. And then yung value niya ng deflection at center at maximum will be negative 27.834 mm. So, ayan. So, please calculate the value of the inertia and the maximum deflection using what we have discussed on the previous slide. Okay? So for questions, you may ask your questions sa GC natin. But if everything is all right, this ends our lecture for today.